Hello friends. So we have a question on trigonometric equations. We are given a function fx for the values of x0 to pi. So we are constrained between 0 to pi values. The first part of the question asks that we have to identify the roots of fx equals to 0. In second part we have to differentiate. So we also have to utilize differentiation in this part. In the third part we have to sketch the graph. In the fourth part we have to solve an inequality. So first let us try to address the first part of the question. Fx equals to 0. So fx equals to 0 cos x square minus 3 sin square x equals to 0. And it is given in the question that we are talking only between 0 to, so we have to keep this in mind. So this is an equation, we can solve this. Cos x square equals to 3 sin square x, dividing by cos x square we get tan square x equals to 1 by 3. So tan x is equals to plus minus 1 by root 3. So we have to identify the values from 0 to pi, where tan x is either 1 by root 3 or minus 1 by root 3. So we know at pi by 6 tan x is equals to 1 by root 3, and at 5 pi by 6, that is pi minus pi by 6, tan x is equals to minus 1 root 3. So the two solutions for this equation will be x equals to pi by 6. Second will be pi minus pi by 6, which is 5 pi by 6. So two solutions are x equals to pi by 6 and another is 5 pi by 6. Now let's move on to question B. In the first part, we have to identify f dash x. So what is our fx? Fx is nothing but cos x minus 3 sin square x. So this is a differentiation. Simple differentiation. We have to use the chain rule. So first, the differentiation of cos square x will be 2 times cos x, and then the differentiation of cos x will be minus of sin x. Similarly, 3 into 2 times into differentiation of sin x is cos x. So this is minus 2 times sin x cos x minus 6 sin x cos x. So this can further be simplified to minus 8 sin x cos x, or 2 times sin x cos x can be written as sin 2x. So this is minus 4 sin 2x. So this is our differentiation. Now let's move to second part. In second part, we have to identify the coordinates of the points on the graph y equals to fx, where f dash x is 0. So we have already identified f dash x. So what we have to do is equate this f dash x, which is minus 8 sin x cos x equals to 0. So this gives sin x into cos x equals to 0. In the values from 0 to pi, we have to see at what values of x the sin x or cos x will be 0. So at x equals to 0 and pi, sin x will be 0. So we have two solutions here. Either sin x is equals to 0 or cos x equals to 0. X equals to pi 2, cos x will be equals to 0. So in all, we have three solutions for f equals to 0. The solutions will be x equals to 0, pi by 2 and pi. So this is the solution of the second part of the B equation. Now in the C part, we have to sketch the graph of y equals to modulus of fx and we have to show various points where f dash x is 0 or fx is equals to 0. So let us try to understand the graph. What is fx? Fx is cos x square minus 3 times sin square x. Now we have few values already with us. We know x equals to, in the first part we have solved fx equals to 0. So we know at x equals to pi by 6 and 5 pi by 6, this is 0, this is pi by 2 pi. Somewhere it will be pi by 4, somewhere it will be pi by 4. Here this will be pi by 6 and here somewhere it will be 5 pi by 6. So we know at x equals to pi by 6 and x equals to 5 pi by 6, the value of the graph will be 0. And at x equals to 0, if we put x equals to 0, we can see this, the graph will be at 1. When x is equals to pi by 2, sin x will be 1 and this will be at minus 3. And at x equals to pi, again this will be 1, this will be 0, the graph, therefore the graph will be equal at 1. So we know, we can draw this graph that it starts from 1, attains 0 at pi by 6, goes to minus 3, then attains 0 again at 5 by 6, 5 pi by 6, then goes to 1 at. Now this is the graph of fx, but in the question we have to identify the graph of modulus fx. So when modulus, what happens is basically all the negative values will be positive. So this part of the graph, because it is already positive, but this negative part of the graph will come on top, going up to 3. So the graph of the function will look like something like this. Something like this. And in the question you can see we have to show various points where f dash x is 0 or fx is 0. So fx is 0 at these points, fx is 0 at these points, and where f dash x is 0, those points are this, at x equals to 0, here f dash x is 0, and at the point of here another point where f dash x is 0. So we have shown all the parts of C. Then in the third part we have to solve the inequality of modulus fx equals greater than 1. So we have to solve this inequality, modulus fx is greater than 1. We have the graph, so from the graph we can see we have to find the values for which this graph is above the line. So if we can are able to identify these points where this line is cutting this graph, between these values the graph will always be greater than 1. So what we will be doing now is, let's try to solve fx equals to 1 or modulus fx equals to 1. So try to identify the values at which this graph attains the value, modulus fx attains the value 1. So what is fx? Cos square x minus 3 sin square x equals to 1. Taking cos square x on right side, we will get 1 minus nothing but sin square x. Square x minus 3 sin square x. So further solving this, if we can bring this to the left side, we will get minus 4 sin square x equals to 0 or sin x equals to 0. So when sin x is 0, the values will be x equals to 0, pi. So these values are these 2 points. Now, since we are solving modulus, so another solution could be cos square x minus 3 sin square x equals to minus 1. Solving this, we will get minus 3 sin square x equals to minus 1 minus cos square x. This cos square is nothing but 1 minus sin square x. So this is minus 3 sin square x equals minus 1 sin square x. Taking this to left side, minus 4 sin square x equals to minus 2. So we get square x equals to 1 by 2. That is sin x equals plus minus 1 by root 2. So from 0 to pi, the values will be pi by 4 and 3 pi by 4. So these are the two values where this graph will again touch 1. And from the graph we can see between this interval, this graph will always be above 1. So for the values of x greater than pi by 4 and less than 3 pi by 4, modulus of fx will always be greater than 1. So this is the solution of our fourth part. So the first part, we have to identify the equation, which are this x equals to pi by 6 and 5 pi by 6. Second part, we have to differentiate the function, comes out to minus 4 times sine 2x. In that part also we have to solve that differentiated equation equals to 0, for which the solutions come out to be x equals to 0, pi by 2 and pi. Then we have to plot the graph of modulus fx, which comes out to be the part of the graph which is in red line. In the fourth part, we have to solve this inequality modulus fx greater than 1, for which the solution comes out to be the values of x ranging from pi by 4 to 3 pi by 4. So this is your complete solution, and for more such questions, visit our website iitnacademy.com and register for detailed explanations.